Find a polynomial p of x of degree 3 that has integer coefficients and zeros 1/2 and 1 plus I. We know that if 1 plus I is a 0, that means that 1 minus I, its complex conjugate, must also be a 0. So we can go through the process of taking these zeros, figuring out the corresponding factors, and figuring out the polynomial. So if 1/2 is a 0, that means that x minus 1/2 is a factor. Now also, we're going to have x minus 1 plus I and x minus 1 minus I as factors. Now, we have already dealt with this particular product, the last two factors, in a previous example problem, so there's no reason to go through all of that work again. We know that when we multiply these two, we're going to get x squared minus 2x plus 2. It's important to keep track of what you've already done, because if you're asked to do it again, instead of going through all of that hard work, you can just say, well, we did this in the last problem, and skip it. So we have this product. Now the thing is, if we go through and multiply all of these out using the table method, we've got this fraction here, and when we multiply negative 1/2 times x squared, that's going to give us a fractional coefficient. Now we could go through and multiply all of this out, and then in the end, multiply the whole polynomial by something to get rid of the fractions. But we can also make our lives a little bit easier by doing the multiplying now. If we take this first factor and we multiply it by 2, that's going to give us 2x minus 1. So this is another factor. It's different from this one, but both of these have 1/2 as a 0. And so this allows us to have the appropriate zeros without having any fractions. So this is a nice way to make our multiplication easier. We're still going to have to set up a table to multiply this binomial by a trinomial, but it's much easier when we don't have any fractional coefficients. So when we multiply, we get 2x cubed, negative 4x squared, 4x, negative x squared, positive 2x, and negative 2. And when we combine like terms, we get 2x cubed minus 5x squared plus 6x minus 2. And this is our polynomial, p of x, that is a third degree polynomial, has integer coefficients, and has the zeros we need. If we hadn't gone through the process of multiplying this first factor by 2, all of the coefficients would be half of what they are now, and we would end up with a fractional coefficient on the x squared. That's why multiplying by 2 makes it easier to do all the math.